In this video, we're going to look at adding, subtracting radical expressions. In the next video, we will look at multiplying radical expressions. So our focus right now is only adding, subtracting radical expressions. Radicals can only be added or subtracted when they're similar or like radicals. What are like radicals? Like radicals are the radicals that have exactly same index and same radicand. That means the number in the pocket is same and number inside the root is same. If radicals are not like, then they cannot be combined by addition or subtraction. Example of like radicals, 4 cube root of 7 and 5 cube root of 7. Both are like radicals and we are adding them. So when we add the radicals, we leave the radical alone and just add or subtract the coefficients, add or subtract the numbers in the front. So 4 cube root of 7 plus 5 cube root of 7 will turn out to be 9 cube root of 7. Think of a radical like a variable x. So if you had a 4x plus 5x, that would equal to 9x. So in the same way, you don't change the x, the variable x. In the same way, you don't change the radical, leave the radical alone, just combine the numbers in the front. Example of radicals that are not like because of different indices and thus cannot be combined. So here's an example. These two radicals are not like radicals because the numbers in the pocket are different. Although the number inside the root is same, but the numbers in the pocket are different. So they are not like radicals and we cannot add or subtract them. We cannot combine them any further. Examples of radicals that are not like because of the different radicands and thus cannot be added. Another example, in this case, the numbers in the pocket are same, root 11 plus root 17, but the numbers inside the root are not the same. So they are not like radicals and thus they cannot be combined. Radicals that do not look like radicals that don't look like radicals but can be manipulated to the same radicand and same index. Here's an example. Root 8 plus root 2. You might say, well, they don't look like radicals, but let's think about breaking 8. We have pairs of two 2's inside. 1 2 comes out, 1 2 stays inside. So now they're like radicals. So if you look at these two carefully now, they have the exactly same number inside the root and same number in the pocket. So they are like radicals. And one more thing to remember, that there is a hidden 1 here. 1 times root 2. Okay. So 2 root 2 plus 1 root 2. We can add or subtract the numbers in the front, which is 2 plus 1 is 3. And root 2 just stays like that. 3 is not the index. 3 is not in the pocket. So it's like 3 times square root of 2. Okay, let's look at several examples now of adding, subtracting radicals. Again, keep in mind we can only add or subtract the radicals if they are like radicals. Like radicals means the number index has to be same and the radicand has to be same. The number inside the root has to be same and the number in the pocket has to be same. Only then they are like radicals and we can combine. So here's an example. 8 root 11 minus 3 root 11. It's easier when you think about, well, 8x minus 3x. Think about the radical like a variable. So if you have 8x minus 3x, what's your answer going to be? It's going to be 5x. We leave the variable alone. In the same way, we leave the radical alone. So root 11 stays there. And 8 minus 3 is 5. So my final answer is 5 root 11. The problem that I'm boxing has nothing to do with the one we were doing. I just gave you an example that think of a radical like a variable. When you're adding or subtracting radicals, think about the radical like a variable. You can only add or subtract the coefficients if the variable is exactly same, in the same way if radical is exactly same. Okay, so this has nothing to do with this problem. 8 root 6 minus 2 root 3 plus 5 root 6. My first goal is to go ahead and break the 6 and see if I can pull anything out of the radical. Well, 6 is 2 times 3, but I don't have two 2's inside or two 3's inside to be able to pull one out. So that means this is already in the simplified form. I cannot simplify it any further. So let's go ahead and combine the like terms. 8 root 6 plus 5 root 6. These are the like terms. 8 plus 5 is 13. So 13 root 6 and then minus 2 root 3. Now these two are not the like radicals because they don't have exactly same number in the radicand. The radicand is not exactly same, so cannot be combined any further. Let's look at number 3. Square root of 27 plus 2 square root of 75x. All right. We can break 27 into 3 times 3 times 3, and I can pull a 3 out. Inside, I'd be left with a 3 and an x. Plus 2, 75 can be broken into 5 times 5 times 3. So there's 2 5s inside. 1 5 can be pulled out. 1 5 can be pulled out. And 3x is left inside. Now, 5 and 2 are actually going to multiply with each other. Now these are like radicals because you have exactly same number in the pocket, exactly same number in the root. So this is treated like a variable. If you have 3y plus 10y, that would be equal to 13y. In the same way, this is going to equal 13 root 3x. Okay. Next example, 6x root 12x minus 5 root 3x to the third. My first goal is to simplify the radicals. So 12x can be written as 2 times 3 times x minus 5, 3 times x times x times x. Now let's see what can I pull out from here. I can pull a 2 out from here. So 6x times 2, inside is 3x. And I can pull an x from here, 5x, and 3 and x is left inside. So this turns out to be 12x root 3x minus 5x root 3x. Well, if you look carefully, these two radicals are like radicals because they have exactly same number in the pocket, exactly same number inside the root. So we can add or subtract the numbers in the front. 12x take away 5x is going to equal to 7x root 3x. 7x root 3x. And that's my final answer here. That's what I got after adding, subtracting these radicals. Next, we have fourth root. Okay, fourth root here. Let's go ahead and try to break these further. 3, fourth root. 32 is 2 times 2 times 2 times 2 times 2. And then we have 5a's minus a, fourth root. Let's see, 162 divided by 4 is 162 divided by 2 is 81. So it's 2 times 3 times 3 times 3 times 3. And then we have an a here. Okay, let's go ahead and simplify and see what can I really pull out of these fourth roots. So because it's a fourth root, for every 4 things inside, 1 can be pulled out. So for these 4 2's inside, I can pull a 2 out. There's 5 a's inside. So for the group of 4 a's, I can pull an a outside. Inside, I'm left with a 2 and an a. And for 4 3's inside, I can pull a 3 out. And then I'm left with a 2 and an a inside the fourth root. So a little bit simplification. 3 times 2 times a is 6a. 6a, fourth root of 2a, minus 3a, fourth root of 2a. 6a minus 3a is 3a, fourth root of 2a. We could combine the coefficients. We could combine the numbers in the front. Okay. Next example. Cannot be simplified anymore. Cube root of 4. You don't have 3 or more 2's inside to be able to bring 1 out. Cannot be simplified anymore, but these two can be simplified. So let's go ahead and simplify. We have cube root of 4 plus fifth root of 4 plus 2 times 2 times 2, or we can just say this is 2 to the 5th power. Cube root 2 to the 5th power, And 128 is 2 to the 7th power. 2 to the 7th power is 128. 2 to the 7th power, 5th root. Again, cube root of 4 cannot be simplified anymore. 5th root of 4 cannot be simplified. But here, I have 5 2's inside. I can pull 1 2 out because I'm looking for groups of 3. So think about 1 2 3 4 5. So for these 3, 1 can be pulled out and the 4 is left inside, cube root of 4. Same thing here. We can write 2 to the 7th as 2 to the 5th times 2 to the 2nd power. And for 5 2's inside, 1 2 can be pulled out and we have 5th root of 4 left over. Now, one important thing to remember, recognize, if you ever see a variable x, it simply means that it's 1x, right? Keep in mind. So in the same way, when you see the cube root of 4, there's a hidden 1 in the front. In the 5th root of 4, there's hidden 1 in the front. So we do have like terms. These are like terms. We can combine them. It would be 2 plus 1 is 3, cube root of 4. And then we also have 5th root of 4 and 2 5th root of 4 as like terms, which is 3 5th root of 4. And that's my final answer. They are not like radicals anymore because the numbers in the pocket are different and we cannot combine them any further. Let's check out number 7. My first goal is to simplify and pull out whatever I can. Looks like I can pull out an x. Inside the radical will be 2y. 8 times, this is 2 times 2 times 2. So I can pull a 2 out. And I can pull how many y's out? Pull 2 y's out. Inside is 2y. So this is going to leave me with x root 2y minus 16y squared root 2y. And now they are the like radicals, but the coefficients are not like to be combined. If you really want to go one step further, you can write it. You can factor out a root 2y. You can factor out a root 2y. Okay, but that's kind of unnecessary. You can go ahead and do it if you want to. Here is example number 8. In example number 8, we are going to break the 108 now. 108 is going to be, let's see, 27 times 4 is 108. So let's go ahead and do the prime factorization. And 27 is 3 times 3 times 3. So that would be 27 times 4 minus 2 times 3 times 3 minus 3. And that's okay, so that's just, I did the prime factorization for 108, 18, and 48. Now, the numbers in the pocket are 2. When there's no number in the pocket, there's a hidden 2. For groups of 2 things inside, 1 can come out. Okay, so from the first radical, a 2 can come out and a 3 can come out, and I'll be left with the square root of 3. From the second radical, a 3 can come out, I'll be left with square root of 2. From the next radical, 2 2's can come out and a square root of 3 is left inside. Let's go ahead and simplify. 3 times 2 is 9 times 3 is 27 root 3 minus 6 root 2 minus 12 root 3. There's my like terms, which is 27 root 3 minus 12 root 3. That would be 15 root 3 minus 6 root 2. Cannot be simplified anymore, and we will stop at this point. Okay. Next example, number 9. We have cube root of 54xy to the third minus 5 times cube root of 2xy to the third plus y times cube root of 128x. All right, so let's go ahead and cube root. 54 is 9 times 6, which is 2 times 3 times 3 times 3, and x, and we have 3 y's. 5 times 2x y to the third plus y. 128 has 7 2's inside. You can write it to the 7th power, or you can write 7 2's inside and an x. 1 2 3 4 5 6 7. Yep. Okay, now let's go ahead and simplify. We have cube roots here. So for pairs of 3 things inside, I'm going to be able to pull one out. There's 3 3's in here, so I can pull a 3 out. 3 y's in here, I can pull a y out. So cube root of 2 is left and an x is left, 2x. Minus, from the next one, there's 3 y's inside. I can pull a y out and 2 and the x are left inside. From the next one, we're looking for pairs of 3. So a 2 comes out, another 2 comes out, and we are just left with cube root of 2x. Okay, the next step is 3y cube root of 2x minus 5y cube root of 2x plus 4y. 2 times 2 is 4 cube root of 2x. Okay, 3y plus 4y is 7y minus 5y is 2y cube root of 2x. Be very careful, stay organized. You're dealing with lots of expressions, lots of numbers, lots of variables, lots of signs. So do it slowly, do it carefully. So take your time and seek help when needed. Here's number 10. For number 10, we have a fraction with different denominators. We can only add or subtract the fractions when denominators are same. So I'm going to do that in a minute, but I'm going to go ahead and try to simplify this y to the 5th here. I have 5 y's and it's a cube root. I can pull 1 y out and 2 y's will be left inside the cube root. Now the next one, we have 5y, and again it's a cube root of y squared. I'm not able to pull any y's out. Now to get a common denominator, I need to multiply second fraction top and bottom with the 2. So leaves me with 5y cube root of y squared over 8 plus 10y cube root of y squared over 8. Now I have the common denominator. I can write it as a single fraction. I do have y plus 10y. I can combine the like terms on the top. That would be 11y cube root of y squared. And that's going to be our final answer, simplified final answer. Nothing more can be done with it. Here's number 11. For number 11, let's see what can I pull out. It's a cube root. I have, let me rewrite it. I have 4 x's, 1, 2, 3, 4, and it's a cube root. So that means I can pull 1 x out for the 3 x's inside. We can pull 1 x out, and I would be left with 1x and a y squared inside. And the next one, we have 5x and cube root of, let me have some difference or gap between 5x and cube root of xy squared. Now, are they like terms? Yes, because my variables are exactly same. Cube root of xy squared, cube root of xy squared. We can combine the numbers in the front, coefficients, which is 4x plus 5x is 9x. And then cube root of xy squared. Okay, again, to summarize, keep in mind we can only combine the radicals when they're like radicals. Like radicals means the same index and the same radicand. If the index is not same and the radicand is not same, then we cannot combine those radicals. Okay, and think of the like radicals as like variables. We don't do anything to the variables, but we only add or subtract the numbers in the front, which are coefficient. In the next video, we will focus on multiplying radicals.